Today we're going to be talking about subtracting rational expressions. So this is going to be the exact same that we did with addition, but we just need to watch out for that negative sign. So we're going to talk about what you should be doing and the easiest way to avoid making mistakes with subtraction. So if we get started here, we have 5 divided by x plus 3 minus 2 divided by x plus 4. So because I see that this is subtraction, I'm going to make it be addition and change the numerator of the fraction immediately after that to be negative, or the opposite of whatever it is currently. After that, it's exactly like an addition question. So the next piece would be to factor any denominators, which neither of these can be factored. Then we're going to find the least common multiple to find our common denominator. So that means that we need the x plus 3 and the x plus 4. So it helps to put these in parentheses to notice that you can't just take that x to be part of it. That x goes with the plus 3, and this x goes with the plus 4. So you need both of those. Since we already have the x plus 3 in the first fraction, we're going to multiply both the numerator and the denominator by x plus 4. So when we distribute that 5 in, we would get 5x plus 20. In the second fraction, we already have the x plus 4, so we need to multiply by the x plus 3. Distributing in, we would get negative 2x minus 6. The next piece of our process is to combine like terms in the numerator, so that would give us 3x plus 14. And remember, the denominator stays the same. We're going to look to see if there's anything we can do to factor or simplify the numerator, but 3x plus 14 has nothing in common, so that's the first part of our answer. Next part is to find our restrictions. So remember, we look on the denominator of our fractions for these, so x could not equal negative 3 and a negative 4. Okay, so as soon as we change that subtraction sign to addition and distribute that negative just to the numerator, then it's the exact same process that we did previously. All right, if we have 4 divided by x squared minus 9 minus 7 divided by x plus 3, we're going to change this to be addition, and the 7 now becomes negative. So now I notice that x squared minus 9 can factor into x plus 3 and x minus 3. X plus 3 over here can't factor, but it does stay together. All right, common denominator time. So they both share an x plus 3. So we've got those taken care of, and we still have this x minus 3 from the first fraction that we haven't taken care of yet. So that's good to go now. All right, first fraction has the x plus 3, has the x minus 3, so it doesn't need anything. We're just going to take that 4 and carry it down. Second fraction has the x plus 3, it needs the x minus 3, and then we're going to distribute. So negative 7 times x is negative 7x. Negative 7 times negative 3 is a positive 21. Keep the denominator the same. Combine like terms in the numerator. So we have negative 7x plus 25. There's nothing to do in that numerator. You could take a negative 1 GCF out, but that's not going to help cancel with anything in the denominator. So I'm just going to leave it alone like this. Restrictions would be that x can't equal a positive or a negative 3 from both of those pieces. So you could write it like this, or you could separate it and say x can equal positive 3 and x can equal negative 3. Okay? Let's take a look at one more full example here. So we have 5x divided by x squared minus x minus 6 minus 4 divided by x squared plus 4x plus 4. Change the sign there and make the 4 be negative. Now this question should look familiar to you. It was the last example that we did with adding rational expressions. So let's go ahead and factor those denominators. X squared minus 6x minus 6 factors into x minus 3 and x plus 2. And x squared plus 4x plus 4 is going to factor into x plus 2 and x plus 2 or x plus 2 squared, however you want to write it. So they both share an x plus 2 in common. We also need an x minus 3. And we need another x plus 2. So I'm going to make that be x plus 2 squared times the quantity x minus 3. To get the common denominator, we have the x minus 3. We have 1x plus 2. So we need to multiply this first fraction by another x plus 2. Distributing in, we get 5x squared plus 10x. The second fraction has both x plus 2's already, but is missing the x minus 3. So negative 4 times x is negative 4x, and negative 4 times negative 3 is a positive 12. Keep the denominator the same. Combine like terms in the numerator. So we have 5x squared plus 6x plus 12. And that is not going to factor at all. Okay, so this is our first part of our answer. Restrictions, x can't equal a negative 2 from the x plus 2, and then it can also not equal a positive 3 from the x minus 3. So that's both parts of that answer. So we're going to look at this example. I put example 4. We're not actually going to solve the whole thing. And typically you wouldn't even see parentheses around this. But if we have 7 divided by x plus 4 minus x plus 3 divided by x plus 2, here when we make this a negative, this first fraction would stay. But this negative distributes in, and we get negative x minus 3, and the denominator of x plus 2 is going to stay the same. So then from here, you would work on finding your common denominator and going through all of your same steps from before. So if the numerator of the second fraction has more than one term to it, you do need to make sure you're taking that negative and distributing it into all of those terms, however many there are. And that's it.